Okay, so we're going to be taking a look at the LDP tunneling in a little bit more detail. So on the top right hand side you can see the two LDP areas and you can see that they're not connected. And then below you can see the same two LDP areas and you can also see both the red and the green admin groups which I've added to the diagram. And you can see that the red admin group pretty much runs exclusively around the edge of the autonomous system, whereas the green tends to cut across. Okay, so what are we going to do? Well, we're going to put on LDP tunneling on the label switch path from router 3 to router 6. Now the path from router 3 to router 6 isn't a straightforward path because it's a red only path. So although it looks initially as if we could connect the two nice and simply here, and logically that's how LDP will see it. It will see router 3 tunneled across to router 6. However, of course, when it comes to the next hops, we're actually following the label switch path router 3 to router 6, which we can see here in the routes. I've shortened label switch path to LSP here, just so that it fits slightly more cleanly on the board. Okay, so if we were to now look at router 3, firstly, we would see that we do have an LDP neighbour across to router 6. So we have the tunnelling on and the neighbour is there. And of course, LDP isn't aware of the relatively tortuous path that it's going to get from router 3 to router 6. And if we have a look here, we can see that for router 3 to get to router 6, the label switch path is either going to have the next hop of router 4 and then 5 and 6, or the next hop of 2, 1, 8, 7 and 6, following the red around the circumference. So let's have a little look. If we look in the route table of INET 3, we see that indeed we have the RSVP route here, and you can see that the next hop of the RSVP route is indeed router 4. So from router 3 to router 6 is router 4. And then below it, you can see that LDP has also added its route here. You can see the admin distance or the preference of 9. And you can see that likewise it's also pointing at router 4. And that can be pretty confusing because if you're expecting the LDP to follow the RSVP and you don't note that the RSVP is going a non-direct route, then this could take a little bit of time to debug in your mind. I'd also like to point out at this point, we have another interesting route here in the INET 3 table of router 3. And if you remember, this is actually the loopback of the route reflector. If you remember that for the route target family, the route reflector was changing the next hop of the routes to itself. And so we lifted that out of the INET 0 into the INET 3 table in all of the routers. And there we can see it. We can see the ISIS generated route inside the INET 3, which is just worth noting as we pass through. Okay, so how do these LDP tunnels work? Well, Junos actually enables IGP shortcuts, and it does it in a hidden way. And the reason it does it so that the routes can be resolved through. So once we have the connection here, the tunnel connection from R3 to R6, we want to be able to break out of that. And so this connection effectively, using IGP shortcuts, is added to the ISIS database so that it can then generate routes beyond it. And so if you have a look again in the INET 3, you can see that in the original it's told us there are some hidden routes. Let's have a look at the hidden routes. And these are the routes that have been enabled by Junos. Here are some of them. And again, the next hop of these routes, slightly confusing because they're router 4, but very clear when you know that the LSP has taken this tortuous path. And then you can also see the next hop of router 2 on the way to router 6, and that's because it's the bypass route for the route that goes via 4, 5 and 6.